Welcome to EDU World Space.
Problem 8.37, we're told of a football tackle that's occurring on a very muddy field, and so the players are able to slip around without much friction that we need to worry about, at least for the duration of time immediately before and after the tackle that's in question. And so we're told that a linebacker is moving north at this speed and with this mass towards the halfback who's moving east with the given speed and mass. And then we'll have what we call T, I guess, for the tackled pair of them moving off some direction north and east with the combined mass of 195 kilograms. And we want to know the magnitude and direction of this. So because any forces acting external to these things are going to be negligible for the situation in question, the conservation of momentum applies. So before the tackle, we have let's do this one first, because we'll call this direction X, and this direction Y. We can also just call them east and west, but So the X component first is going to be the mass of H times the initial speed of H in the X hat direction. And then L is going to be moving in the Y direction. L initial, Y direction. This is going to be equal to the final momentum, where the mass is going to factor out of here, and we'll have the X component of the final velocity, unsurprisingly enough, in the X direction, plus the Y component of the final velocity in the Y direction. So then we can solve this. This is technically because X hats and Y hats don't add together, and they basically form. We could have written this as a system of two equations, and in fact, we can write down the final speed in the X direction is going to be the mass of halfback times mass of both of them times the halfback's initial speed, and the Y component is going to come from the linebacker with an equation that is otherwise identical. So this works out to be 3.14 meters per second. And this is 4.96 meters per second. Now, to find the magnitude of this, of course, this is always going to be just the sum of the squares of the components, and then take the square root of that. And that works out to be 5.9 meters per second. And then if we take the direction, the angle north it is from east, we call that theta. That will be the arctangent of the ratio of the y component of the velocity to the x component. And to remember how to do this, imagine we have any vector you like, which in this case v could be for velocity or for vector, dx, dy, theta, and then we know that the tangent of theta is the opposite over the adjacent, and then just take the arctangent of both sides, and you get theta equals arctangent of this ratio. And then putting these numbers we had before in, we get that the net direction is 58 degrees north of the east.